Hello, my name is Daniel Gaskell. I'm a paleoclimatologist currently at Yale University, and I'll be presenting some experimental work that I did with Claire Bowern, also of Yale, testing whether the Voynich Manuscript could have been hoaxed. So the Voynich Manuscript is an undeciphered codex, and a central point of debate over the last century has been whether the Voynich Manuscript actually encodes meaningful information, or should instead be regarded as a medieval hoax, essentially devoid of linguistic meaning. And central to this debate are the peculiar statistical properties of the Voynich text. If we think about a continuum of meaning from a completely meaningful natural language text on the right to pure random noise on the left, Voynichese seems to fall somewhere in the middle. On the one hand, Voynichese exhibits a number of properties that are not typically observed in natural language, such as low conditional character entropy and a high degree of similarity between adjacent words. On the other hand, Voynichese exhibits other properties thought to be indicative of natural language, such as obeying Zipf's law or showing regularities in word morphology. Network analyses have also identified patterns of topic words and large-scale information structures which resemble meaningful documents. So, proponents of the meaningful text hypothesis would argue that Voynichese is too non-random to be meaningless, while proponents of the hoax or gibberish hypothesis would counter that Voynichese does not resemble any known language or cipher system, so what could it possibly mean? The implicit assumption underlying much of this controversy is that if the Voynich manuscript were genuinely meaningless, it would appear random. We challenge this assumption. If the Voynich manuscript is indeed a hoax, it is likely that the Voynich scribe or scribes would have generated the text intuitively rather than by relying on an explicit generative algorithm. So that is, rather than rolling dice to generate pure random noise or pulling grills out of a hat, the scribe simply invented words or phrases as they wrote in order to create the intuitive appearance of language. And because literate humans have an intuitive sense of what written language looks like, the resulting text could, in theory, be significantly non-random. So in order to determine whether the Voynich manuscript is too non-random to be meaningless, we must compare it not simply to random noise, because very few people would argue that the manuscript was generated by purely random processes, but to real human-produced samples of meaningless text. So that's what we attempt to do here, by collecting real samples of intuitive gibberish to test against the Voynich manuscript. And we addressed four main questions here. First, how well can intuitive gibberish replicate the properties of meaningful text? Second, how well can intuitive gibberish replicate the properties of the Voynich manuscript? Third, are there markers which can be used to distinguish meaningful from meaningless texts? And fourth, in aggregate, does the Voynich manuscript more closely resemble meaningful or meaningless text? So how did our experiment work? We collected a total of 45 short text samples from volunteers consisting of handwritten documents containing meaningless text. 39 of our participants were students participating in a Yale undergraduate course on the Voynich manuscript taught by Dr. Bowern. Another 3 were recruited from the public and had no knowledge of the study's connection to the Voynich manuscript, and 3 writing samples were also contributed by the experimenters. All participants spoke fluent English, but a range of other language backgrounds were also represented, including Latin, Hebrew, Spanish, Cantonese, and Australian indigenous languages, among others. We gave our volunteers an instruction sheet telling them to create a document by filling 3 pages with fake, meaningless text in a language that you should make up as you go. Ideally, this language should not actually mean anything, but should appear realistic enough that most observers would not be able to distinguish it from a real language they simply did not know. In other words, we're asking the participants to use any means they choose to create a fake document that looks real. In order to better replicate the scribal conditions of the Voynich manuscript, participants were instructed to write in pen without punctuation and to use the lowercase Latin alphabet to facilitate transcription. Our completed documents look something like this, which we then transcribed into Unicode text documents for statistical analysis. Now, it's important to note here that because we don't actually know what the generative approach of the Voynich manuscript might have been, we intentionally did not give our participants an explicit algorithm to follow when generating their gibberish. Our intent here is to capture the distribution of outcomes which can occur in gibberish documents, rather than simulating one specific algorithm which may or may not have been employed. So these data allow us to test whether it is possible for the Voynich manuscript to be gibberish, but not necessarily to identify the exact method that was used. It's also important to note that our participants did not simply develop their own encipherment systems for meaningful text, but they were instructed to generate documents that had no linguistic meaning at all, albeit ones that were intended to have the appearance of linguistic meaning. Now, I should also point out that 2 of these groups of participants, the 2019 class and the experimenters, had some advanced knowledge of the statistical properties of the Voynich manuscript. This might create a risk of data contamination due to these participants trying, intentionally or unintentionally, to replicate the statistical properties of the manuscript. However, we found that excluding one or more of these groups from our analysis did not actually change any of the conclusions that I'm about to present. Okay, we need something to compare these gibberish documents to, so we compiled a corpus of 75 comparison texts spanning a range of languages and language families, both historical and modern, and included a roughly equal number of technical texts, such as medieval herbals, and more linguistically literary texts, such as the New Testament. We also included a range of constructed languages, including Esperanto, Klingon, and lolcat, the sort of mangled English popularized by late 2000s cat memes. For Voynichese, because the appropriate transcription and interpretation of the Voynich glyphs is uncertain, we included both a minimally decomposed V101 transcription and a maximally decomposed EVA full and EVA basic transcriptions, as well as the courier A and B subsets in EVA basic. And this allows us to test the properties of the Voynich manuscript as a distribution of possibilities rather than assuming which transcription method is most correct. To compare the gibberish samples to these texts, we needed a way to characterize the form and structure of a document without being dependent on its linguistic meaning. So we devised a total of 42 statistical metrics to be applied to each document, and I'll refer you to the paper if you'd like to see how each of these were calculated, but they broadly fall into 4 categories. For metrics dealing with information content, we have compressibility, which is basically the total unique information in a sample. Second order conditional character entropy, which is a common metric in the Voynich literature, similarity of unique vocabulary words to each other, and the similarity of adjacent words to each other, i.e. How similar is each word to the word immediately preceding it. For vocabulary and alphabet, we calculated the number of unique characters, words, and character sequences, the distribution of word and character frequencies, the distribution of word lengths, and the LMZ statistic for how closely a text obeys Zipf's law. For spatial structure, our gibberish samples are too short to calculate very large-scale metrics of text structure, like identifying topic words, but we generated metrics for the bias in where specific characters were likely to appear within a line or word, where specific words were likely to appear within a line or 200-word text sample, and a metric for the autocorrelation of word lengths, which I'll talk about in a second. For repetition, we calculated metrics for the frequencies of flipped word pairs, repeated characters and words, and triply repeated characters and words. So now for some results. Our results for individual metrics look something like this, so I'll walk you through what these plots mean and then show you some more aggregate results in a second. This plot shows how closely a text obeys Zipf's law, which is a classic way of identifying a natural language by looking at word frequencies. So each of these lines represents a different category of text, with Voynichese at the top in magenta, gibberish towards the bottom in green, and the other lines representing various other kinds of documents. So each of these dots is an individual text sample, and the colored regions are kernel density estimates to give a sense of what distribution of results we observe across all samples, or what is the most likely outcome. We can see that Voynichese at the top seems to obey Zipf's law about as well as many meaningful texts do, which has been used by some authors to argue that the Voynich manuscript must be meaningful. Our gibberish samples show a wider spread, with some obeying Zipf's law quite well, and others not so much. This suggests that Zipf's law can be a good way of identifying if something is not meaningful, but just because a text obeys Zipf's law does not necessarily mean that it is meaningful, because many of our gibberish samples do that as well. So the fact that the Voynich manuscript obeys Zipf's law does not necessarily mean that much. Another interesting observation that has sparked much debate is that Voynichese seems to have a much lower conditional character entropy than most natural languages. That is, the stream of characters tends to be more predictable than you would expect for meaningful text. And we find that gibberish can exhibit a range of different entropy values, but is actually overall more likely to have a low entropy than meaningful texts are. Another interesting statistic, which has only rarely been discussed in the literature, is the autocorrelation of word lengths. Word lengths in most meaningful texts are negatively autocorrelated towards the left of this plot. That means that long words tend to be interspersed with short words. So long, short, long, short, long, short, like yesterday she traveled to Singapore. By contrast, the Voynich manuscript exhibits positive autocorrelation. That means that long words tend to cluster together rather than being split up by short words. So long, 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 short, short, short. Positive autocorrelation is only observed in a limited number of natural languages like Sanskrit and Yoruba, but interestingly, it's quite common in gibberish samples. And I'll talk more about why that might be later on. All right, so these are some interesting individual metrics. Now let's talk about our results in the aggregate. This plot is a summary way of showing you the information from all of our metrics in one plot. There's a lot more going on here than I have time to get into, but I encourage you to check out the paper if you're interested in this. Each line is a different metric, which is then scaled so that the vertical black lines represent the range observed in meaningful texts. So the placement of these bars relative to the vertical black lines indicate where the results for other categories fall relative to the results for meaningful text. So to focus on the metric for repeated words as an example, the gray bar here represents the range observed in gibberish documents. And we often see a lot more repeated characters in gibberish documents than we do in meaningful text, so the bar extends off to the right. The red bar represents the range observed in Voynichese, where we also see a lot more repeated characters than are typically observed in meaningful text, but not as many as we see in some of our gibberish samples. These numbers to the left encode a lot of information, but basically this column here is telling us what percent of gibberish documents overlap with the range observed in meaningful text. Basically, how likely is it that any gibberish document resembles meaningful text? And here on this metric, the answer is 35%. So it can, but it may not. This column tells us what percent of Voynichese samples overlap with meaningful text, which is 0%. So Voynichese does not look like meaningful text at all on this metric. And then this column tells us what percentage of Voynichese samples overlap with the range observed in gibberish documents, which is 100%. So the high percentage of repeated characters in Voynichese is hard to explain if it's meaningful language, but easier to explain if it's gibberish. Zooming out, we can actually see that this pattern holds true for a lot of metrics. So this column has a lot of green for every metric. At least some of our gibberish samples resemble meaningful text. That means that gibberish is actually relatively capable of reproducing the properties of meaningful text, despite the fact that it is, well, not meaningful. This next column is a bit less green. Voynichese resembles meaningful text on many metrics, but not all of them. And finally, this column is a bit more green, meaning that Voynichese actually resembles gibberish on more metrics than it resembles natural language. Now, while these numbers show that it is possible for gibberish to replicate meaningful text, or Voynichese, it also has some tendencies that can be used to distinguish gibberish from meaningful text. So compared to meaningful text, gibberish has a statistically significantly lower average information content, lower average character entropy, higher average occurrence of repeated characters and words, a higher average bias in where characters appear in a line and where words appear in a 200-word section, higher average autocorrelation of word length, and they tend to obey Zipf's law less precisely, as we saw earlier. Gibberish documents are also more likely to exhibit really high numbers of tripled characters and words, though the average occurrence rates are not significantly different than natural language. So interestingly, all of these tendencies are observed and in the same direction in the Voynich manuscript. So to return to our initial research question, we can now answer some of these. Can gibberish replicate meaningful text? And the answer seems to be yes. While not all of our samples resemble meaningful text, some of them do get pretty close. Can gibberish replicate Voynichese? On just the metrics we measured here, on just these short text samples, the answer seems to be mostly yes, with a few caveats that I'll get into later. So can we distinguish gibberish from meaningful text? Again, it's not always possible, but the answer seems to be yes. There are tendencies that it has that natural language does not have. So our final question, does the Voynich manuscript look more like gibberish or more like meaningful text? This is difficult to answer. Subjectively, so far, we might say gibberish. Gibberish seems to be able to replicate the anomalous properties of the Voynich manuscript better than natural language, and Voynichese seems to exhibit some of the same anomalous average tendencies that gibberish does. However, we can also try to answer this question a little bit more quantitatively. And to do that, we employed random forest classification. So this is a common machine learning approach to automated classification that is robust to overfitting in the presence of large numbers of collinear variables, so it's ideal for our data set. And essentially, we're asking the computer here to teach itself to distinguish between gibberish and meaningful documents using the metrics we've collected, and then we give it the metrics for Voynichese and ask it which category it thinks that they're more likely to belong to. So this plot is similar to the metrics plots I showed earlier, except that the x-axis is now the classifier's opinion of how likely a given sample is to be meaningful. And our machine classifier identified all 5 samples of Voynichese as more closely resembling gibberish than natural text, albeit with low confidence. Of course, we're only comparing 2 categories here, so it's possible that Voynichese would be an even better match for some third category that we're not testing here, perhaps some kind of encipherment. Before I move on to some kind of concluding discussion, let me comment briefly on the visual and artistic properties of the documents that our participants generated. Samples varied greatly in layout, from uninterrupted streams of text to carefully formatted pseudo-documents with illustrations, labeled diagrams, and text arranged in stanzas or geometric patterns. A majority of our participants retained an English-like sense of vowel usage, which yielded text that could subjectively be considered pronounceable. Unexpectedly for a meaningless text, some samples actually contained strikeouts or corrections. The Voynich manuscript notably contains few corrections, which has been argued to indicate that it was either a copy or perhaps that the scribe simply didn't care about the meaning. But here we have examples of participants correcting text that looked wrong to them, even when it was explicitly meaningless. We observe that in some portions of the Voynich manuscript, text is wrapped around the illustrations in a way which appears to have perhaps required the scribe to have chosen words of specific lengths to fit. And what I mean by this is that if the order of words on the page were randomized, the quality of the text wrapping would noticeably deteriorate, suggesting that the word lengths might have actually been chosen to improve the text wrapping. It's possible that the Voynich scribe simply employed non-standard word breaks in these cases. Alternatively, we hypothesize that in the absence of a linguistic meaning that would predetermine word lengths, gibberish writers might actually be inclined to self-select word lengths which improve the text wrapping. So to test this hypothesis, participants from our 2018 class were encouraged to write their samples on stationery, which contained a selection of plant illustrations from the Voynich manuscript. Well, other participants were allowed to draw their own illustrations if they were desired. And in total, 31 samples included illustrations, of which we assessed that 17 showed some evidence of word lengths being selected to improve the text wrapping. So this finding is very difficult to quantify rigorously, but these observations do suggest that the text wrapping features observed in the Voynich manuscript may also be common in gibberish documents. All right, so what does this all mean? I want to say up front that we cannot and do not attempt here to prove that the Voynich manuscript is gibberish. We can't do that with our results. Our results do, however, invalidate some traditional arguments that the small-scale structure of Voynichese on the character-to-paragraph level is too non-random to be meaningless. Even without an explicit generative algorithm, intuitively generated gibberish can both adequately replicate many features of natural language and produce a wide range of other unusual properties, depending on the author and the text in question. So if the Voynich manuscript is indeed gibberish, it is perhaps not surprising that it would appear to be both language-like and in other ways statistically unusual. In statistics, the concept of a null model refers to the simplest explanation for a dataset against which other models can be tested. And much Voynich research to date has implicitly used this null model of pure randomness, effectively arguing that because the Voynich manuscript is less random than rolling dice, it must be meaningful. We propose that a more appropriate null model is that the Voynich manuscript was generated by intuitive gibberish, such as that produced here. In order to prove that the Voynich manuscript is meaningful, in other words, we need to show that it is less random than human-produced gibberish, not simply that it's less random than rolling dice. So while these results cannot conclusively establish whether the Voynich manuscript is gibberish or not, they help to establish the baseline of what such gibberish might actually look like. A more significant limitation of this work is that because of the short lengths of our text samples, just a few pages, we're unable to test whether gibberish can replicate the larger structural features such as topic words which have been observed in the Voynich manuscript. And at present, these features pose a pretty serious challenge to proponents of the hoax hypothesis. However, while it would be premature to assume that gibberish can replicate these features, it is equally premature to assume that it cannot. In theory, the properties of a scribe's gibberish might drift considerably over the course of the weeks or months required to generate a Voynich-length manuscript, which would induce significant large-scale non-randomness. If the scribe then took breaks between sections or only kept out material from the current section to reference when they were copying vocabulary, further spatial patterns might arise. Insofar as possible, our results do appear consistent with this hypothesis. The presence of topic words may be consistent with some participants' reports that they made conscious decisions about word associations, even if the exact meaning of those words remain undefined. So, for instance, one 2018 participant captioned an illustration "pit shoal" and then used the words "pit shoal" or "pit shoal" with an H repeatedly in the paragraph surrounding it. Word distribution biases in our samples also resemble or exceed meaningful text at the 200-word scale. However, whether such simple processes can reproduce the structure observed across pages and sections of the Voynich manuscript remains to be tested. It is also unknown whether such processes might tend to introduce too much spatial variation, destroying any recognizable consistency of the gibberish. A viable approach to future work, albeit one that maybe has its own uncertainties, may be to use the lessons here to construct automated algorithms that can produce larger volumes of gibberish, similar to the method of Tim and Schinner. Our results are generally consistent with this proposal that the Voynich manuscript was generated by a process of self-citation. That is, that the Voynich scribes generated the text largely by copying and modifying words appearing earlier in the same section. This process is argued by these authors to explain both the finer and larger scale features of the Voynich manuscript. Now, informal interviews and class discussions confirm that many participants did indeed adopt this type of approach to generate their texts, although they generally did so intuitively rather than by developing an explicit algorithm such as that published by Tim and Schinner. We hypothesized that such processes of self-citation and self-correction may explain many of the unusual features of gibberish. For instance, some participants reported a tendency to write a series of long words and then realize they hadn't written any short words recently, and then self-correct by switching to short words. This tendency may be responsible for the observed positive autocorrelation of word lengths. Elsewhere, inaccurate perspectives on the prevalence of certain language features may have led to participants generating vocabulary that felt realistic to them, but was more homogeneous and lower in information content than real language. By incorporating these observations about human behavior into automated text generating algorithms, future work may be able to more effectively test whether the Voynich manuscript is meaningful.